Hola, 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 chicos, ¿qué tal? Muy buenas. Gracias por participar en el chat hoy, por participar en el broadcast hoy. O, bueno, para los que eventualmente se integren, si les gusta el broadcast, este broadcast, si gusta este video de lo que hago, y pues les doy la bienvenida. Pueden participar cuando gusten integrarse en algún momento. Yo de momento tengo pendiente continuar con las colisiones de este pues renderizador que ahora mismo está, está en esta circunstancia. Veamos, ejecutar el estado actual de este renderizador. Muy bien, listo. Ahora tenemos algunas cosas extrañas y es que aparece otra instancia de nuestra entidad en la esquina superior derecha, ¿no? Y eso es porque tengo la sensación de que nos hace falta algo para poder depurar la visualización de aquellas cosas que son invisibles usualmente, ¿no? Como los bounding box de las colisiones. Eso. Entonces dejé algo de implementación en el código para ver si se puede continuar hoy. Pero vamos a tratar de retomarlo desde donde dejamos el broadcast anterior, ¿no? Si no me equivoco, estábamos, estábamos hablando en el broadcast anterior que de aquí podíamos sacar elementos de colisiones como objetos y construirnos en base a estos objetos nuestros bounding box, ¿no? Y se supone que el player va a colisionar en estas partes de aquí cuando, cuando intente pasar, ¿no? Esto solo es nuestra meta información. Hay que llevarlo plasmado hacia el código, hacia C++, para, para hacerlo funcionar, ¿no? Y después de hacer eso en el tile, vamos a, vamos a tener que transformarlo en código legible para C++, ¿no? En algo, en un elemento legible para C++. Y eso dijimos que lo íbamos a tratar en el Python que tenemos aquí, que es parte de nuestro mecanismo de baking, ¿no? He logrado integrar otra parte del Python y aquí ahora vamos a encontrarnos con otras clases. Sobre todo estas clases Object y Collision Layer. Esta clase lo que hace es em, leer la información que nos viene del tile a través del JSON, de nuestro archivo JSON, que es, que es este tm3 tmg file, test3 tmg file. Esto tiene la información, la metadata de nuestro tile. Eso lo he hablado en otros broadcasts. Está muy familiarizado. Si ves los broadcasts anteriores, verás que esto está muy... lo hemos hablado muchísimo. Y, y básicamente lo que leemos es nuestra información basada en JSON, human readable. Y después lo que tenemos que hacer es hacer un baking. Y quien hace el baking es nuestro Python. Ya hemos comentado también que hacerlo con Python es un poco más... Es el lenguaje para eso, ¿no? Para usar. Scripting language es un poco más rápido de ponerlo en producción, en marcha. Así que... y no necesitamos, en el baking no necesitamos high performance compilation, ¿no? Así que es el lugar para hacerlo. Este, este video va a ir mucho en español, me doy cuenta. Igual es. No, no, tan buena idea. Voy a tratar de switchar to English in any moment, but right now I will continue speaking Spanish. Okay, hopefully you can understand. I mean a bit of Spanish. If not, you can practice with me. Okay, I will try to do it in Spanish mostly. Okay, guys, this is just to you know to be consistent with my stream with my streaming, because I said I had tags saying this is English to Spanish. Both languages are welcome. So I will try to be more consistent. Okay. So here we have our collision layer. As I was saying, we have now a class that holds the information for the collisions that we have in the tile file. And each collision has object, and this object, although is kind of generic, the name, this object right now are the collision bounding boxes. I have stored some information using this class and then transform this using the struct class of in Python language. This is kind of built in, okay? This is not a special package. I mean, you have to import the package for struct, of course, but it comes with the built-in, I believe. So yeah, so it's very easy to find this, how this class works. If you don't remember from my last broadcast, I can tell you that this struct takes formats, and these formats like tell the struct how it's going to store the information in binary format. This format are just letters here. So you have some letters where that said to the struct that this will be like an unsigned integer of 32 bits, for instance. And I have this for convenience. These names are for convenience, right? I just don't want to go back to the documentation and see what is the capital A means. That's all. Anyway, having this, I store the layer information, the collision layer information, the header. I mean, mostly like data related with the collision layer, because the collision itself, I mean the bounding boxes, will be in another file. I want to organize in this way right now. Maybe I will like kind of merge all the tile information and collision information in a single file, but right now I believe is the right way to do it. I mean, to have a MVP, of this project. I think I was yelling, guys. Sorry. I will try to not be so not to be so loud. Okay. And yeah, then I just run this file and I generate the binary file, and then I read from Python. Sorry, from C++. And I have some modification, of course, in C++ to read the binary information, and that is in level 5. Yeah, here now I have the information from collisions, and using this I have just some data of the collision layer, some number of collider. I know from our notes we have spoken that we will have like one single layer and do it bitwise masking to make the collisions, to organize the collisions and the layer of collisions. But I still implement this as we will have several layers of collision. But yeah, anyway, I believe it's a good approach to have one single layer and have a bitwise masking to do it. To handle different depth of collisions. Yeah, but that's why you see here you have a number of collision layers. But yeah, probably it will be just one single one, and when we decide finally how to be the right approach, we will refactor this code. Right now, I think it's yeah, I think it's pretty decent. So you as you see here in our game RAM state enter this state, we now read some map and some collisions. So we have now the collision voting boxes in different file, and we map this file to read in efficient way. Okay, this is a memory map strategy file reader. Yeah, and I have this to to handle all my information about collisions in the binary file. Excellent. So that is more or less the things we have done now, and yeah, we can now go further and try to implement the following. We have several paths. We can continue doing some rendering of the collisions voting boxes. One thing is we have here we don't have at least this render custom render doesn't have hierarchy of the entities. You know, there is no parents and child and children for that parent, and so all the coordinates of the entities are like war coordinates. So maybe in the future we should implement something like that inside the entity components, and because of course it's the only way we can make the data persist using components. So maybe we can create a hierarchy using components, and then modify the transform component to make coordinates for children and related to the parents. That's it. One thing. But anyway, so that means what that means is rendering voting boxes will be put it in like in exactly in the movement system here. Maybe we can we have to update the position of the voting box as well, because of course it's like an independent component with their own coordinates, and those coordinates are global. So yeah, it's kind of not that good. I mean, it's sloppy, let's say, but it's the way to have something in the code that you can work with. Anyway, then assuming we're going to handle that in the ABB component, which I think is the reason that here, yeah, is the reason that we have this this second entity of the Nadir in the game, because it's always in the 0 position. You know, it's always in the 0 origin of the word, because it doesn't get update. Maybe if we can set here, let me check, guys. I think we are going to go for that path here. In the word render, we have a new function. This function is a overload of the main function. I mean, on the function of the word render that we have used to render all the things in the map right now. here, but this sorry, is this one. This one is the overload. Yeah, I was looking for the other version, you know, guys. But yeah, this is one of the overload. I have overload this function to this version, and you can see some differences. Here, these functions, the parameters, the, the parameters are different. Yeah, that is the concept of overloading actually. So in the text coordinate here, I store the text coordinate when I am going to use it, a texture. So here, this function is just for render, like a quad with color. That's all. But of course, that also implies that I need to modify the shader as well. And I think that is the second entity of Nadir. It's weird that maybe when I render, when I send the quad of Nadir, that quad is still in memory when the second quad is sent. That is probably what is happening. Let's inspect this here. As you can see, guys, here I send the transform component position, so I get the position, and this transform gets updated in movement system. So that's why we are in the center of the screen. And then I send the position of the ABB component, which is the bounding box, but this is not updated. Which is most important here is, here I didn't send any, oh, don't forget it. I am using the texture coordinates version of the function. That's why I use the nadir text. Forget it, guys. I'm crazy. Okay, never mind. So this one way to do it, like add in some debugging shapes to know where are the collisions bounding boxes. That is actually very good. Or we can just continue implementing the collisions, which is, yeah, it's necessary, of course, but maybe we can play a bit with the shader, and we can finally see how are the shaders written. Actually, it's not that a big deal. It's not a huge shader, because it's just, for 2D it's very simple. But yeah, that could be a possibility to do today. So let's dive in. Yeah, let's do that. To add some debugging shapes, I believe it will be a very good idea to have this, but separate, Hey, hello there. Not existent 1945. Welcome in. Yeah, you are my first viewer. Thank you very much. Thank you very much. I mean, yeah, it's mean a lot to me. I hope it's going well. Yeah, it's going well. Thank you. How you doing? Everything is alright. Huh? Thank you. I believe you are maybe as English speaker. Assembly. Wow. Whoa. Yeah. That is hard. Maybe assembly for an embedded system. None is yes, assembly is yeah, kind of using a specific flavor, or is Intel assembly, I don't know. Yeah, I mean, I have a code in assembly. Oof, I mean, maybe in the university I touch some code, and also doing some, exercises of reverse engineering. But yeah, it's hard. I respect a lot people that work in assembly. It's not easy. Yes. Okay. I was saying maybe. I understand why you're saying yes. Yes, happened to me with this. I mean, it's not like assembly, but I also, get. I am used how this codes or everything in the GPU works, graphics, instead of using, as you said, layers of abstraction that you only use for in using some functions to get the things done. So that's why I'm doing this in C++. I instead of using an engine, I mean, I am a fan of the engines, but instead of doing it in an engine, I decided to do it in C++ just to have, some touch of this. Of course, doing an assembly will be, you know, for me, it would be, I mean, in my opinion, would be very difficult. Indeed. Yes. Yeah, now, anyway, welcome, man, and or I'm not assuming your gender, but yeah, welcome him. I'm trying to code some debugging stuff here because I want to see the collision bounding boxes of my colliders. I'm trying to implement that. I have some ideas right now. Really, a quicksort algorithm, right? Uh-huh. I see. I see. Yeah, that sounds great. That sounds great. It was, I mean, it was even faster. Did you try? Yeah, yeah. Did you try maybe and measure the time between an implementation in C++ and an assembly? Uh, did you achieve a very, very different results? I mean, I'm curious actually. I'm generally curious because is when you do some code in assembly, actually you can combine C++ and assembly code, right? But you try to decide which part of the C++ code will be in assembly, so you can game a very very fast code. So I would like to know if you achieve a very good result with assembly in your quicksort algorithm, different than C++, I mean. Did you try it? Did you measure? Huh. Position, scale, texture, no, this is color, has to be color. Haven't benchmarked it yet, but believe me, if you want to speed your choose C, compilers may not be perfect, but you will suffer trying to optimize assembly by hand. Yeah, can imagine. I can imagine it. Indeed. Yeah. I mean, if you try it, I would like to see, you know. So that is the essence of doing some optimization in your code to see if you achieve different results. Yeah, people complain about. I mean, you use the tool that work for you, right? I mean, people complain about some languages that it's so slow, or maybe they are not done good for memory management. But yeah, I mean, if you use the wrong tool for the job, it will be like that. So yeah, it's like the common sense of programmers, right? But yeah, anyway, it's different people, different opinions. Um, okay, so yeah, I see here we can do it like this. And I have some question here right now because here I have my structure, my structure, the vertex structure here. I have this struct and I have this int, which is the flag that decide if this quad will be, at least this vertex will be like the vertex for texturing or the vertex for doing the quad. I mean, plain quad. But using this, of course, I need to modify the previous implementation of this patch, this patch vertex buffer, and I think I let's check. Let's check how this is implemented. How did I implement this? I barely remember. Hmm. Yeah, I implemented this some time ago. What I did was, yes, I create a buffer, of course, and define the size of that buffer. Here I send, yeah, but this is the end. I need to check the definition of the buffer. This one will be, this is it. Yeah, here, yeah, I implemented dynamically. You know, I mean, the max squats is just a constant. Then I multiply this by 4 because it will be 4 vertex. Yeah, it's just a quad. And this is the size of the vertex structure. So when I include this, is yeah, it's computed dynamically. So that is correct. Then this change maybe every draw. So dynamic draw is the correct flag. Then I use element array buffer. So I define an element array buffer. Then this will be 6 because of course I need 6 vertex to implement a quad, but 6 indices actually is the correct way to say it. And these are mostly static because yeah, I mean a quad is in the device coordinate. It's just that. And yeah, I think that is correct. Also want to try US dev sometime. I mean, you mean develop a operative system, something like that? Yeah. Oh, I see. Yeah, developing the operative system. I have done some exercise back in university. I met a guy who is actually a very good programmer. You know, in assembly, in C and C++ as well. And that guy was coding a OS, sorry, and I help him a bit, and I see how difficult it is. I mean, I tasted, right? Because of course we do some classes in that, and the professor said how difficult is this and that, you know. But I tasted in the in the first hand how difficult is that. We were implementing the interruption of the peripherals, you know, and it was playing with these interruptions, a low level hardware, and implemented the drivers of this. I mean, all the stack of the drivers was not yet in the university, but doing good on coding Olympiads. So why not try? So you are in the high school right now? Maybe you are at high school. Yeah. Oh, I see. So you are kind of talented coder. I mean, it's being in high school and writing some assembly code is Nice. Nice. I believe you will be very good at coding uh, in any language. I mean, yeah, because you have developed your logic, right? I mean, you have studied logic, how to some discrete mathematics as well, probably. Yeah, yeah. I mean, being that curious is very good. I started programming 1 year before the university as well. A friend of mine back in the day told me, this will be very important for you if you go to the university, because that friend went to the university first, and he told me, you know, I see you are very interested in computers, so why not to learn how to code? And he gave me this book because he was already past the class, and he told me, take this book. And it was, maybe you have seen this book, but wow. Anyway, the name is Datel and Datel C++. How to code in C++ was like this. Datel and Datel. These two guys was this book. And yeah, this book in the it appears some flies in the cover. And I started playing with that book and do all the, I mean, I read it all the way. And yeah, when I reached university and started the classes, it was for me like easy peasy. Yeah, I really think that man. Yeah. We are not friends anymore. I moved to other country. It was difficult to be in touch. But yeah, I bless that guy because he gave me this very nice gift, Yeah. Okay. Where is this going? I think this is. Oh, of course, I need this index, this attribute. Yes, here I'm coding the layouts of the shader, right? Let's inspect the shader code. GL, this one. Yeah, we'll put it here. Let's call out this. Here it is. Here's the map. The map code between C++ and GL shaders. You are maybe also interested in computer graphics as well. If not, you are here just for I don't know, but probably if you are, is this is kind of the way you connect the information. You are interested in computer graphics. Nice. I also interested in computer graphics a lot. It's not like my main topic I learned in the university. Because also I decide to have some different skills for the market. I mean, you can have several tools to get your foot into the door. You have some jobs and get some money and stuff. So I decided to study several aspects of the computer science, and one of those aspects was, of course, computer graphics, but also other approaches like web servers, cybersecurity, all that stuff, just to have some handy tools for me to get into a company. But yeah, I decided to start this as a hobby. It's like I mean, one day I say, I love to make some graphics back in the university, and I would like to go back to that. And yeah, I just start doing this, and this is how it goes right now. This is the knowledge I have remember and get, and something like that. Really? Forgetting all your games, we don't even or GPUs. The OpenGL is melting my mind, my brain. Yeah. At the beginning, it's kind of very hard. I mean, it was very hard for me to get into it. But now it's becoming more and more, more comprehensive. And this, I mean, according to some professionals' opinions, this OpenGL is kind of the easiest API of graphics. And well, I think, okay, I will start with this, and then when I want to move, I will do in my steps. And I have a clear roadmap I will share with you. Maybe it was for you as well. I decided to start with this because they say it's easier. It has level of abstractions, the OpenGL, and because of that, has some limitations as well. What kind of limitation? You probably wonder. Well, one of the limitations are, since OpenGL is based on state machines. I don't know if you are familiar with state machines, but state machines, let me do some graph for you in our whiteboard. State machines, I will do some new here. State machine is like a structure to define the behavior of an element or an entity, okay, of a system as well. For instance, graphically, you see states and you see transitions to other states. So this, sorry, this is too big. These are 3 states. And you have transition to other states according to some conditions. I mean, you go from state 1 to state 2 using the transition, and these transitions needs to meet a condition to transit here, So probably you are thinking, okay, but what kind of transition? That is decided by the information outside the state machine. This is the state machine. And the state machine has some inputs here. And these inputs are evaluated every time. And when, let's suppose you are in the state 2, and the inputs of the state machine decide if you are in the state 2 and the conditions are met, you transit to another state. OpenGL is like that. You establish several conditions, and for each condition, you know that your OpenGL will be in a state. And if you like to move to other state, you have to change the conditions sent into the OpenGL through the functions. This is the way the API is implemented, right? And this is kind of not loosely coupled, and that's why it's kind of difficult. Regex for video cards? Not exactly. I mean, it's possible. It's possible to see in reg expressions as a state machine. It's possible. Actually, it's an implementation, a very good implementation of reg expression are done with the state machines, of course. But it's like the core of our reg expressions are the state machines. Okay, this is a possible way to implement it. So you are not that far from the concept, but it's very easy. Let's put it in an example here. Imagine you have a semaphore here. You have a red, green. I think green is this one, right? Green here and yellow. Okay, and you have a tiny robot here that looks for this semaphore. All right, look here. So the way you implement this, the behavior of this robot is using a state machine. You define a state machine for the movement, right? So the movement here is defined by this state machine. And why the state machine is good for this, you may ask. The state machine is very good because you can just focus in one state at a time and separate the code from the other states. I will show you my implementation of the state machine right now in the code. Hopefully you can see it because of course it's a code, so it's kind of massive. Okay, I will back to the whiteboard, but I will show you what I mean with state machine. I have implemented state machines in some past broadcasts, so I'm very fresh in my mind. Here, this is the template of a state machine. Sorry, not a state machine, or a state. This is the template of a state. And you are seeing here 4 functions. These are like the most common function of a state. This function gets executed when you just transit to the state. This function gets executed. What I mean is this. Here inside each state you have the 4 functions, right? Enter, you have change state, run, and exit. Change state, run, and exit. To be honest, this is kind of not that common. I need it for my purposes, but the most common are this one. These 3 functions. So when you go into a state, you go to enter function and you execute the code of the enter function just once. Just when you enter. So that could be probably if you want to implement the robot movement, this state will be idle, not move. And when the idle state happens, so when the sensor of the robot see the red light activated, right? So that means the red light, the sensor sends some information to the state machine and say, hey, now I'm seeing red. Okay, we have to transit to idle because it's red. And I need to execute the code for that purpose. What could be that code using this logic? So probably you need to stop the motors of the robots, right? Just stop. Could be one way because you previously you were moving the robot, so that means the motor were activated, but so you have to stop the motors. And then what happened in the run state? The run state is you execute the code in the run state every time you are in the state. Every time, but just every time. Which frequency you mean? 1 second? Every second? Every minute? Which is the frequency? That's depend. Depend. Why depend? Because that depends of the delay you want to implement. Maybe it's every second you check for the sensor. Every second you check the sensor what the sensor is seeing right now. You check that every second, and you probably said, but I can just run it and let it run as fast as it can. Probably it's not a good idea, because maybe you want to check other things and you need to make the processor to check that other things. So if you saturate the processor every time using this, it will be very consuming for him. So you can not attend other actions, likely, no? Anyway, that is the idea. You run the code and run function every time. Exit. Well, exit is executed when you exit the state, right? What could be the code in exit? Well, that depends. In our example, it doesn't make any sense. I mean, it's like, what would be? Because when I transit to walk-in state, in the enter state, I will activate the motors. So why do I need an exit state? Yeah, in this example, you probably don't need it. But anyway, since this is a template, you just will have an empty function. And that is okay, because maybe in the other stage you also will need it. So that is the example in this context. In the context of the game is similar in this actual situation, because is if you are not moving the character, you are in idle state, right? In the idle state, you perform the enter, the run, and the exit. So when you move the character using the controls of the keyboard, so you receive in the state machine, you receive that input, and then you change the state. You will see the code of this. As you can see, it's a very tiny code. And when I want to just touch the state of idle, I will just touch this code. It's not like a massive number of lines and having all that spaghetti code. You know, this is one of the advantages of using this approach. And this approach is implemented in every engine you will use. If you are interested in using like Unreal Engine, you will see you have a blueprint of a state machine, and it's the same principle. Or using Unity, and Unity is not that explicit like in Unreal. And sorry, and Godot kind of, yes, it's also in the, it's kind of explicit, but it's the idea. You get the idea by study the pattern, which is this is a pattern behavior. Okay. Sorry, I will discollapse this because the chat is interrupting. There. And that's it. You can see here I implement the direction as well of the movement, because of course I could be idle but looking at front of the screen, or idle looking to the left, or idle looking to the right, you know. So I implement also here that, because doing too much states will be like not worthy. I mean, it's just one condition, as you can see. So you don't overkill the solution, right? And yeah, this is the way you implement the state machine. I mean, this is one implementation, of course. You can just have several implementation. There are several ways to implement this, maybe more dynamic or less dynamic. It's up to you. It's up to you how it works. So what I was saying previously about a state machine is the OpenGL state machine, right? And it's kind of difficult to parallelize the behavior of a state machine. That's why they say OpenGL is not that good when you do multi-threads engine or renders. So that means if you want to do more performance, to achieve more performance in your code, it's likely you will do Vulkan probably. Vulkan doesn't have all this level of abstractions, and the code is more loosely coupled. But this, of course, since you are not done, since you don't have these layers of abstraction, of course, it's more difficult to play with it. You know, to play with Vulkan is harder than in OpenGL. So then you can move to other API like DirectX, which is kind of related to Vulkan, but also had the advantages of not being based on a state machine, but of course has this learning curve more pronounced because they don't have a layer of abstractions. And which you should go first? Well, it depends. If you want to go to Vulkan directly, it's okay. I mean, it will be like, yeah, you will learn Vulkan. There are a lot of resources for Vulkan today. Or maybe you can take my approach and start simple with OpenGL and then move to Vulkan. It's up to you. You know, it's up to the people. There are a lot of resources, so I believe it will be no bad going to Vulkan first. Is some people decide to do it. Um, what maybe will which could be the best to go into the industry, you know, if you want to get a job to as a graphic programmers or in a studio that code with their own engine or own graphics, which could be the API. That is a hard that's hard to answer because it depends, to be honest. Oh yeah, yeah. I know you have the whole university ahead of me. I know, I know you are. But what I mean is like, okay, I'm interested in this. What could be my best options? Yeah, it depends. I mean, if you are doing something in Microsoft products like in Windows, you can go to DirectX because yeah, it will be better since the operating system understand these functions better than other operating system. You know? I mean, it's a Microsoft thing. But I know what you mean. I just yeah, I was losing trying to help you and to make a decision. But yeah, you are right. But anyway, this is the things you are going to see in the university because I am assuming you are going to study computer science or something like that, right? Or it just for hobby you are doing some computer stuff. Oh, it's not your first language. Sorry, I assume it was your first language. It's not Spanish. It's not neither. I can also speak Spanish if you are a Spanish speaker. No, no Spanish as well. Oh, in any case, well, anyway, hopefully I couldn't give you some nice explanation about this steam machine stuff. Okay, let's try to see. Eastern Europe. Oh, I see, I see, I see, I see. I see, I see, I see. Yeah, yeah, yeah. I see, I see, I see. Yeah. Well, anyway, thank you for, you know, being a nice company. Yeah, a nice chatter as well. Okay, so let's try to connect. Uh, if you're willing to, let's try to connect this C++ with the shader. So I'm trying to connect using this layout instruction. This is layout instruction. As you can see here, I have some layouts, which is like defining the connectors through the GPU shader and the C++. So here I have the same like the same order of the layouts uh, to connect with the GPU. I have text coordinate here. This is the layout location 1, layout location 1, color, which is a vector as 4. I have here layout 2, location 2, a colors, and this is 4 elements because this is a vertex 4. This is location 3, which is this location 3, text index, and this is one single float because this is one float. Okay, and this is my new location attribute, which is the location 4. This is an int, it was single int, so I had to change this to yield int, right? This is like match data types with this data type. That's it. This is for compilation conditions. I was trying this, but I will comment because I will do it. I will try to play with it later. Right now I will comment it. Yes, macros are insane. Yeah, well, it's a way to conditionally compile your code. They are nice if you know how to play with it. I have some here. I will try to show you. No, it's not here. I have some in the code for me to have some the book stuff here. Texture descriptor, get texture ID here. Yeah, but should I learn basically a different programming language for macros? No, I mean, you don't need to understand macros all the way. I mean, they are present in different languages. You have in C#, in F#, C++, of course, and also in the shading languages you have. But they are coming to you. It's not like you have to understand it. No. I think it's not necessary to worry about it. As you know, as you go into the languages, you will just understand it because they are not that hard actually to see it. As you can see here, they are just conditions, but they are executed. They are executed in the compilation time, not in the runtime. What I mean is this if you are looking at this if, is executed in the running time. When you run the code, this condition will be evaluated by an if. Contrary, a macro like this is evaluated at compilation time. When the code is compiling, this condition is evaluated. It's very easy. It's evaluated in compilation time. What that means is, you know, I mean, you code in assembly, so you know that when you compile a code, this code gets a machine code, right? Ah, I see. Because when I read the solution to the Olympians problems, I can see just how insane the creators of them are. You don't need a macro for yeah, but they still do. Yeah. It's, I mean that's when you do that a macro like that is yeah, it's annoying. Why do you do that? Yes, I know what you mean. Yes. Yeah, that macro is evaluated at runtime, even though. So it's different than this, I'm sure you. Yeah, I see what you mean. Yeah, it's insane. So those Olympians are kind of, something in your country. I mean, you are very. I know if you already pass or you are into it right now. It sounds to me like the math Olympians, you know. I know they don't mean much, but it's nice to boy attend some unnecessary lesson. No, 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 no. But maybe, I mean, if meant to you, it's enough. No? It's not like yeah, they are not that good at math Olympic. No, if meant if it's meant for you, it's enough to say that they are meant. You know, it's not. Yeah, yeah. I mean, I will not compete maybe because I am already a professional coder, but maybe as a judge, I would be happy to see some teenagers trying to solve problems and making fun and having fun of different this coding problems because I believe it's coding problems. Since you told me that you code a quicksort algorithm in assembly, that means yeah, it's coding problems. That's nice. I think it's nice. I wish I had something like that back in my high school. I didn't have it. It would be very interesting. Would be very interesting for me. As I said, I started coding before going to the university. So if something like that was in my country, I will definitely take it. I would have learned more probably. I want to put some number here. 0. 0. Yeah, this is 0 type. And this is 1 type. Okay. So I'm trying to send the type of the quad to the shader, and I will do that with the vertex information. So the quad, which is not a textured quad, it will be 1, and the textured quad will be 0. Yeah, it's kind of sloppy, but it's a way to have it. Quad type, and here I need to make the distinction. Yeah, I need to send this to the vertex shader, fragment shader, sorry. What type? This is a quad type. There you go. So in the fragment, control fragment shader here, I need to put an end here. This will be vertex quad type. There you go. And so here I need to decide how to use this. Oh, I will take some time to go for some water. So if you are still here, I will be right back in those 5 minutes. If not, thank you very much for having a chat with me. It was very nice, the conversation. So I will be here very soon. Okay, let's continue. Let's see if we can finally implement this. I'm wondering if we can do some ternary stuff here. Text coordinate. Of course, we don't receive the texture, so we can go conditions. Okay, let me check, guys. I need to look for conditions. Will be just condition with if and else, I believe. Hmm. Yeah, let's try this. Here. If and else. I believe this will work. There you go. Else. Yep. And here, bracket color will be just the color. Yeah, texture emphasis. There you go. Accent. Yeah, this will be here. So if B quad is 1, it should be this one. It will just render the color. If not, it will be rendered the texture. Okay, before going any further, I need to activate my log. This log interface is something I have to test the see the debug information of the GPU using this GLSL code. So yeah, I need to first activate that. So give me a moment. C++. You go. One day I will configure this so you can see it, guys. But it's not. I mean, it's not like it's just a log, a bunch of lines in the screen telling me what is going on behind, you know. And that is all I need to see, or to make some decisions according to the log information. There you ready. Now let's compile. But first, let's see if we have the code ready. Here. Position, scale, and color. This will be just white, right? Yep. So if I put in here, let's compile. Okay, compile well. Now let's let's execute it. And here I'm seeing the traces. Yeah. Now, if I go here, we push this vertex data using 1. So now our vertex data has a different type of vertex according to the quad type. So let's inspect. Let's see. Quad is 0, 0. Ooh, we'll be very with 0. Which is this one? Will be the last one, but this is just one single. It's this unfortunate. I don't have a way. Maybe if I inspect size. Let me modify this, guys. Inspect size. Huh. So maybe. I don't know if it's possible to do this. No, the operator doesn't work. Okay, yeah, it's possible to do it like this. Nope. Yeah, we don't have access to that memory probably. Ah, how can I? 300. Wait. Yep. No. So weird. I thought we were in the... Ah, but it's the quad, of course. Yeah. If we multiply the quad... Let me check, guys. Oh, yeah, it's exactly the size. Because if you multiply this... Well, not exactly, but sort of. Anyway. Let's put it in action. Yeah. 224. And yeah, it was an error. There was an error. Let's continue. So as you can see, guys, it's just red screen. Yeah, there is an error. And I am seeing my traces, my login traces going crazy because maybe they are telling me there's an error. Yeah, they say security type error, invalid error, generate program. Yeah, the shader is not working. I wish I could show you this, guys. See, I think I can make it very quick. Show you guys. Let me see if I can add it very quick. Weird stuff. I cannot show you guys. Why not? Let me try again. Huh, interesting. Can we show you guys the logger information? Okay, I will need to check. Anyway, actually I think I can show you, but the postmortem. Yes, I think I can show you the postmortem. I will pause this and I will try to open the file where I, dump all the log information. So it's just for you guys to see what I'm seeing. Projects. Then log game information. It's too large. Yeah, this is kind of gigabit. Ooh. Of course, it's too large. Okay, guys, I need to erase this. Because it's too big right now. Let me just erase. And then go back. I will execute this again. Will be red as well. And then I'm going to read the new file. Will be shorter. That's it. So now if I put this to this, let's see guys. As you can see here the error, old type error. Yeah, the shader is not working, or it's not a program. Yeah, I need more information. Maybe when I compile, I have also traces when I compile. Here, they are around here. Huh? When I compile the shaders, I also have some traces. Let me see if I can find it. I cannot find it. No, it doesn't. It doesn't look like I traced that kind of errors. Nah, would be very silly error, guys. Probably. Which let me see if I can find it immediately. I don't know if it's the fragment shader. Oh, okay. I can use read the doc, or I can see at the moment of the creation in entry point, moment of the creation of the renders. Maybe I can find here when I perform, when the code is get executed. Let me try. Let's see very quick. Well, we have a very nice. Yeah, today I'm happy. I'm happy today. Definitely having one Shatter is it's nice. It's nice. I think that guy was is very nice. Hopefully he can or she uh, can achieve a very nice, a very good level of coder. I think he is kind of motivated. Yeah, let's see. Maybe it's not in shader, but I will inspect shader as well. I think compiles well. Let's see, rack main shader. Huh, compile well as well. What? Oh, sorry, but it's control shader, of course. Huh? What's happened? Here. Let's repeat that. Let's see. Doesn't complain. What? Why is not complaining? Did I modify? Did I did something? I will need to check in RenderDoc probably, guys. See what is going on. I mean, it looks fine to me, but of course it's not working, so it doesn't work. Attach, finalize the program. Program info log. Green program log. Oh, I see. It's weird. This trace, we didn't see it previously. Look, this is what my tracer say now. I will write here in the comment. Look, it said, hey, fragment info. The error is code integer variant what must be flat. Must be flat. Let's search for a translator. What is that? What that means? Flat qualifier in GLSL. Must be flat. Smooth shading those. Huh. I think okay. As flat. Yeah, I had to declare it as flat. That is the problem. It's the first time I see this. So I should learn how to declare as flat because I don't know if it just has to be like flat int like this. No, I don't think so. Yeah, anyway, I will try to study that and I will go back, guys, to this because, yeah, that's interesting. Yeah, it's kind of a way to say you don't have to vary this data because it's not part like this for different fragments. It has to be constant, something like that. You know, if flat is the keyword for that, I had to learn how to declare that. Yeah, it's an OpenGL shading language specification. So a variable qualified as flat will not be interpolated. Instead, it will have the same value for every fragment within a triangle. This value will come from a single provoking vertex, as described by the OpenGL graphic system specification. A variable may be qualified as flat, can also be qualified as centroid or sample, which will mean the same thing as qualified as only as flat. Yeah, that's it. I had to do it like that. Okay, now I have learned one new things today. Very good. So excellent. Close this, and that's it. Okay, okay. I think that was a nice session, guys. Thank you very much, and thank you to not non-existent 1945 to have to be the principal chatter of this session. Thank you to thank you to you. Thanks to you. Let's see what is going. Okay, never mind. I will put here to do erase this because I will need to erase some time. And that will be, guys. Thank you very much. If you are watching this broadcast offline, so I'm encoding custom render for a game I'm doing, and I upload this of YouTube as well. I have a channel there when I upload my past broadcasts, so you can see what I did previously. If you have any questions, you can also write something in the comments, and I will try to answer any question you may have related to the code. And also, yeah, mostly I do stream on Fridays, and I do some streaming, of course, Monday as well. And time to time, I also do some short videos or short streamings at night. You know, to be constant in the coding adventure. And yeah, thank you very much, and see you next time.